The double-slit experiment, originally invented by Thomas Young in 1801 to prove that light is in fact a wave, which however, now light is known to be bundles of electromagnetic waves called photons, proven by Albert Einstein and James Maxwell. Young constructed this experiment by shining light through two thin slits, and as a result diffraction occurs and an interference pattern is formed on the screen behind the slits. This happens when two waves interfere with each other and crests combine with crests to create stronger crests, and the same happens with troughs. This is called constructive interference. But when peaks and troughs meet, they cancel each other out. This is called destructive interference. So when photons are fired through the slits one at a time, it is expected to see two lines in line with the slits, because the photons can't interfere with each other because they are being fired one at a time. However, an interference pattern still occurs. When electrons are put through the same experiment, the outcome is the same. This shows that all small objects exhibit wave-particle duality, which means they exhibit properties of both waves and particles, proposed by Albert Einstein. Now if one slit is blocked, there will be one line on the screen in line with the slit, but when the second slit is opened, the interference pattern appears. When the particles are initially fired, their positions will seem random, but as time goes on, the pattern will begin to form. The only way to tell what the particle is doing is to put a detector, such as a camera. However, now that the detector is present and the particles are being fired, there is no interference pattern, only two lines in line with the slits appear. This happens because the act of observation causes the wave function to collapse, resulting in the two lines and not the diffraction pattern. So the particles could be splitting, going through both slits at the same time and interfering with themselves, and thus creating the interference pattern, but it can't be observed, so nobody knows exactly how this happens yet.